Today's topic of discussion is small scale multipath measurements. So basically, a multipath is a very important for analyzing the wireless communication scenarios. So when we talk about what is multipath propagation, we'll consider this scenario where we can see from this mobile station MS1 to the base station, there are several links passing through. So the scenario is the link between mobile station and base station is established, and the link is not a straight direct path, but rather it has multiple paths. The wireless signal takes multiple paths to reach from this transmitter, that is mobile station, to the base station. So mainly this multipath propagations creates small scale fading, and due to the small scale fading there are certain effects and this is listed. That is the first one is a rapid changes in signal strength. Signal strength will decay, will suddenly increase, will suddenly decrease, based upon this multipath propagation for a small distance of travel. And due to this rapid change in signal strength, it induces the modulation in the modulation change in the signal frequency. That is due to the Doppler shifts that occurs on different multipath signals. And final one is echoes, that is time dispersion, which means the signals will be reaching at the base station at different times. So there will be a delay, and it is also can be termed as echoes. So this is the multipath propagation. So to analyze multipath propagation, there are several methods. In order to analyze the channel effects due to this multipath propagation, the three methods are followed. That is, one is RF, direct RF pulse system. Second is spectrum sliding correlator channel sounding. The third is frequency domain channel sounding. So these techniques is also called as channel sounding techniques. The reason is using these methods, the channel can be analyzed and the effect of multipath propagation can be analyzed. So we'll see that one by one. The first is direct RF pulse system. So this method mainly helps to determine the power delay profile. We'll give the power delay profile directly. To obtain this power delay profile, there are certain arrangements to be made. So the main objective is to find the impulse response of this signal. Upon giving the impulse response, what is the response of the system? That is RF pulse system output is mainly meant to be. And for that, input signal is nothing but a narrow pulse that is used at this transmitter end. Upon receiving this signal, it is further amplified, and it is viewed in a CRO on a detector using a detector. Okay, and then in this is a scenario of of a direct RF pulse system. So FC is nothing but a carrier frequency. This pulse generator will generate the narrowband pulses, and upon multiplying this pulse with carrier frequency, it is further amplified and transmitted. And this is the wave that is actually sending from the transmitter end, which we can see the series of pulse, narrow pulse, having a pulse duration of pulse width of tau BB, and it repeats at regular intervals, and the time period between the first pulse to the next pulse is nothing but tau rep, that is repetitive pulse. So this pulse is allowed to be transmitted, and after a certain short distance of length, a receiver is placed. Upon receiving this signal, first it is passed to a band pass filter having a bandwidth of 2 by tau BB. It allows only the required frequency, and this band pass filter ranges, upper and lower cutoff ranges, are mainly decided by this nature of the signal and frequency of the transmitted pulse. And further, after identifying the signal through a band pass filter, it is further amplified, and detector is mainly used as envelope detection, that is used here, and the DSO is used to view the signal after detecting this signal. Its resolution is nothing but pulse width, that is nothing but the tau BB terms of resolution will be fixed at DSO in order to have proper visualization of the transmitted pulse. So the direct RF pulse system is very simple to implement, but it certain problems are encountered during this measurement process. The main problems is interference, and there are presence of noise is higher due to a wide band pass filter. So since a band pass filter is used, it will allow certain range of frequencies. There may be an there may be a chance of allowing the noise frequencies, noise signal also. So again, since the detector is nothing but envelope detector is used, the phases of the individual components are not received because of the use of envelope detector. So if I replace this envelope detector by some other detectors, then we can able to obtain the phases also. These are the general challenges in direct RF pulse system. So the next method is spectrum sliding correlator channel sounding technique. So the spectrum sliding correlator is mainly used for CDMA signals, that is code division multiple access signals. That is the major application area of this particular technique. So here the probing signal is a wide band, but the receiver is narrow band. So we will see the block diagram. The first one, the topmost blocks represent the transmitter, and this represent the receiver block. In the transmitter end, we can see the carrier frequency FC is there, and it is multiplied with the PN sequence, which is generated by a PN sequence generator. So PN sequence is nothing but a pseudo noise sequence. It is uh, random numbers of sequence will be generated, and this is fed by a transmitter chip clock. So upon having a multiplier, FC and the PN sequence will be multiplied and amplified. It is transmitted through the air. Upon receiving, again, wide band filter is used similar to the direct RF pulse system, and direct RF pulse system has a problem that it also allows more noises. So then. This received signal from the band pass filter is then passed to a multiplier to remove the multiplied PN sequence at the transmitter, so that the same PN sequence is used at the transmitter and also receiver, but having a different rate. So the transmitter chip clock rate is slightly faster than the receiver chip clock. So the reason is, since the transmitter has to come, then only the receiver has to be synchronized. That's the reason. So then further the signal is passed to a band pass filter, which is again a narrow band filter. So it further reduces the presence of noise. It allow only the required frequency which contains information, not noise. So this narrow band pass filter will have a bandwidth of twice of alpha minus beta, where alpha is nothing but transmitted chip clock rate and beta has receiver chip clock rate. So after applying to this narrow band pass filter, mostly the noise will be removed. Only we will be having the original signal that is further amplified and detected using an detector. It will be visualized using a digital storage oscilloscope DSO, having a resolution of 1 by um, RC times of RMS pulse width. So generally, this PN sequence length is always 2 power n minus 1. So these are the mathematical terms related to this spectrum channel sounding. So the chip rate is RC, which is inverse of 1 by TC, and RF bandwidth can be calculated by using 2 times RC, and processing gain is nothing but the ratio of 2 RC by RBB in terms of the chip rate, and 2 tau BB by TC is nothing but in terms of time. So generally the gain is nothing but signal to noise ratio at the output divided by signal to noise ratio at the input end. So to obtain the time resolution, we can go for calculating 2 by RC. So again, the sliding factor is nothing but gamma alpha by alpha minus beta. So generally, the observed time at the DSO is not the actual time of propagation because of the sliding factor. So actual propagation time is nothing but observed time by gamma, where gamma is a sliding factor. So since sliding factor plays a major role, this kind of technique is named as spectrum sliding correlator. Slider means catching up the correlated signal and removing the correlation in a perfect way using this sliding factor. Sliding factors mainly adjust to catch up the transmitted signal perfectly. The advantages of spectrum technique is it improves coverage range using the same transmitted power to the top RF pulse system, and there will be a proper synchronization mm, elimination by using sliding correlator. And the drawbacks are real-time measurement is not mostly possible, and the time requirement is more, and it involves complex PN sequence generation and multiplication, and so on. So phase information is here also the phase information is not retrieved because of the use of envelope detector. The last method is frequency domain channel sounding. This is the representation of frequency domain channel sounding technique, where the transmitted signal is given to a equipment called as vector network analyzer with swept frequency oscillator. By using this VNA, S parameters can be analyzed, having a two ports. So we can analyze four different S parameters, namely S11, 12, S21, and S22. So here, since we are analyzing for two ports, S21 is calculated, which is nothing but the transfer function y of omega by x of omega, which is the h of omega. So after obtaining the gain, actually, this is actually the gain in terms of S parameters. Isolation, we can say that we will send the signal of the VNA to the inverse DFT processor, and upon having this inverse DFT processor, it will give the time domain response of h of t. This is a Fourier transform inverse of h of omega. So the drawback is it requires careful calibration. Mainly VNA requires the periodic calibration, and synchronization between the transmitter and receiver is actually a wired, it is not wireless. So VNA measurements are mostly suitable for indoor channel measurements. We cannot take this measurements to the real-time field scenarios. So it is perfectly suited for laboratory measurements. So if the channels are time varying, then the response will give some error values, which will again further can be reduced by. So generally here IDFT is used in order to convert back the frequency signal into a time signal. Thank you. The advantages of split spectrum technique is it improves coverage range using the same transmitted power to the top RF file system, and there will be a proper synchronization mm, elimination by using sliding correlator. And the drawbacks are real-time measurement is not mostly possible, and the time requirement is more, and it involves complex PN sequence generation and multiplication, and so on. So phase information is here also the phase information is not retrieved because of the use of envelope detector. And the last method is frequency domain channel sounding. This is the representation of frequency domain channel sounding technique, where the transmitted signal is given to a equipment called as vector network analyzer with swept frequency oscillator. By using this VNA, S parameters can be analyzed, having a two ports. So we can analyze four different S parameters, namely S11, 12, S21, and S22. So here, since we are analyzing for two ports, S21 is calculated, which is nothing but the transfer function y of omega by x of omega, which is the h of omega. So after obtaining the gain, actually, this is actually the gain in terms of S parameters. Isolation, we can say that we will send the signal of the VNA to the inverse DFT processor, and upon having this inverse DFT processor, it will give the time domain response of h of t. This is a Fourier transform inverse of h of omega. So the drawback is it requires careful calibration. Mainly VNA requires the periodic calibration, and synchronization between the transmitter and receiver is actually a wired, it is not wireless. So VNA measurements are mostly suitable for indoor channel measurements. We cannot take this measurements to the real-time field scenarios. So it is perfectly suited for laboratory measurements. So if the channels are time varying, then the response will give some error values, which will again further can be reduced by proper calibration. So generally here IDFT is used in order to convert back the frequency signal into a time signal. Thank you.